All right, I just have the top of the hour. I believe that we should get started. Hello, everyone, and welcome to today's webinar, The Current State of DevOps in 2016, brought to you by Avnet Academy and WebAge Solutions. Our speaker today is Gary Tracek of WebAge Solutions, and I'm Laura, your moderator today. I'd like to take just a few minutes before we start to go over some housekeeping items. During the webinar, everyone's phone lines will be muted. If you have questions, please enter them into the chat box, and we'll answer them during the question and answer portion at the conclusion of the webinar. The webinar will be recorded for future on-demand viewing, and we'll be sending everybody who registered a playback link after the webinar has concluded. Thank you, and please enjoy the webinar. Mr. Tracek, you may begin.
Thank you, Laura. Okay, let's see if we get this page changed. All right. Greg Tracek here with WebAge Solutions. We're a provider of training and consulting services on a number of topics, DevOps included. We have we talked about how to ask the questions, etc. What we're going to talk about is what is DevOps. It's a new, hate to use the word buzzword, but a new term that has been saturating our consciousness for the past couple of years. We'll look at some of the critical terms and tools and things we need to think about with DevOps. And we'll have a quick look at some of the confusion or some of the conclusions, Freudian slip there, I guess, some of the conclusions that come out of the Puppet Labs State of DevOps report. We're not associated with Puppet Labs and don't consider this an endorsement, but they do make a nice product. And they do conduct a survey in conjunction with PricewaterhouseCoopers once a year on where DevOps is in adoption and some of the issues that go around it. So it's an interesting survey and I think has some interesting conclusions that we can take a look at. And we'll talk a little bit about lean thinking and then just let you know how we can help. Okay, so what is this DevOps thing? Apart from the kind of obvious conjoining of the words development and operations, what do we mean by that? And to really understand what DevOps is about, I think we need to step back and say, what is this software industry about and what are we using software for? It's obviously something to do with software development. But DevOps is really the process of serving customers using software. And it looks at this operation, this functionality as a process. You, of course, get to define what you mean by customers, so that's internal or external, or who uses your software. You also get to figure out what the service is that you're providing. But in the end, what we say is that DevOps is all about making sure that whatever we do with software serves our customers, and we from there. And by treating it as a process, processes turn out to be open to being analyzed. And this is kind of a new idea in software development, I'd argue, but only because software development itself is a fairly new idea. But the idea of service processes and the idea of making customers or clients happy by doing a number of operations has been around for hundreds of years. So traditionally, DevOps, the process of serving customers usually spans requirements development, software operations, and then actual service. You may recognize that as being fairly similar to the traditional software development lifecycle in some aspects. Software development lifecycle sometimes doesn't look very much at the actual provision of service at the end of it, but requirements development where it rolls in. Traditionally, development and operations have been separate activity, which is why the software development lifecycle that you probably have seen in introduction to programming classes doesn't include what happens when we're in operation. Those activities often seem to have competing goals. They really don't, but like a lot of business activities, when you drill down, things start to look like competing goals, even though they're actually just different aspects of serving the customer. DevOps seeks to enhance the following aspects of the process: collaboration of people, so that we get everybody on the same side and pushing in the same direction; convergence of process, so that our process of creating and delivering software and delivering service through that software is cohesive so that all the steps in that process drive eventually towards that customer service goal. And creation and exploitation of tools, it comes out of the realization that once we have collaboration of people and conversions of process, that can't take place in a vacuum. We will need tools and techniques to do that. And the goal of it all is to make provision of services seamless and frictionless. Okay, so what is this convergence of process? Well, again, I point out that although software development and delivery of value through software systems, really becomes dominant in the past 15 or 20 years, I guess. The idea of process and the idea of a sequence of steps that leads to delivering value to customers, if you take it out of the software context, it goes, all the way back at least, well, you can talk about Henry Ford, I suppose, but even if you go back to the late 1700s and Adam Smith's Wealth of Nations, he talks about divisions of labor. So this idea of process is not new. So DevOps looks for convergence of process. This is efficiency is doing things right. Effectiveness is doing the right things. In the past 30 years, certainly in software, but also in manufacturing and knowledge industries in general, there have been some trends. Agile, ITIL, theory of constraints, lean thinking, otherwise known as the Toyota production system, or as we used to call it, Japanese manufacturing methods. All of these things build on process theory. Okay, and if you look at it, and sometimes it's explicit, sometimes Agile makes explicit use of lean and Kanban thinking, and that of course comes directly out of the Toyota production system. And all of it really comes from, Drucker and Taguchi and a number of, Deming and Durand, a number of prominent business thinkers in the early to mid 20th century. DevOps builds on that theory. DevOps says, let's apply some of this reasonable thinking in building things to the act of doing things, not just building things. So DevOps builds on process theory, and a lot of that process theory says just don't do things that aren't required. That sounds kind of like a silly statement, but it's not, because if you look at most business processes, and software development and software operations are good examples of this, you'll probably find things that are not required, according to somebody's opinion, and that's where the collaboration of people comes in, is to get everybody thinking the same way. Minimize waste. Don't build things, don't do operations, don't sign pieces of paper that don't actually get used. There's a rich minefield of things to find waste in. Use appropriate tools and processes. And if necessary, develop appropriate tools and processes. Software people are sort of unique in their ability to go ahead and do tools relatively easily. We're not talking about building robots or welding or machining. We simply have to edit some text, and we can build tools. So we have things a little easy that way. Root cause analysis, the old doctrine of ask why 5 times. Don't ask. It's not enough to say why is this failing? Why did that error get in the first place? Then why did that error get there? And then why did that error? So that takes us back to the root cause. And then mistake proofing is kind of an interesting philosophy that comes out of the Toyota production system. Tools we have found are critical to DevOps. Things like software configuration management, continuous integration, and along with continuous integration, Jenkins, not just continuous integration, but also as a remote job execution facility. Provisioning tools become really popular, things like Chef and Puppet, and they very much go with virtualization in whatever you're doing virtualization. And Docker has begun to make quite a large name for itself in the past couple of years. There are some questions beginning to arise around whether the hype is justified. A lot of people are on the bandwagon. Things like repository managers. When we start to look at process, one of the key things in any process analysis is what are the things that move from one step in the process to another. In a manufacturing process, that's easy. I have a thing, and there's something I can put my hands on, or I can put into a basket and move from one spot to another. What is that in a knowledge-based process like software development or software deployment? Well, those things are artifacts, and artifacts are files that we need to be able to find and we need to be able to move around. Hence, repository managers like Nexus and so on begin to be important. And really, anything that encourages flow is an important tool in DevOps. And so that may be things like whiteboard software, things like whiteboard software. A whiteboard that's in the middle of an office can encourage flow. So really, we think in terms of processing, think in terms of keeping things moving. An interesting way I found to view DevOps is, although we talk about DevOps as a common thing, when we get down to it, we really have two groups involved in sort of development deployment. We inevitably have development operations, and DevOps is meant to span the two of them. But in development, we have people creating software, creating systems, creating configurations, creating architectures. In operations, we have people operating those architectures and operating those systems for direct service to customers or clients. And things, those systems move from development to operations through some mechanism which I've labeled on this diagram as mysterious release engineering. And that's not really I'm not really making a value judgment. I'm making an observation that often when you look at things a little deeply, there's a lot of parts of this process of the way things move from development to operations that are mysterious in the sense that they're either not documented, or the criteria for completing steps are not documented, or maybe nobody knows, or maybe we just count on someone signing off on something being ready. And that's that mystery. We can't process manage mystery. So one of the first tasks of DevOps is to remove the mystery from that mysterious release engineering. But this process happens in a couple of contexts, or perhaps across a couple of contexts is a better way of putting it. It happens within a social and process environment that either supports process-oriented thinking or it doesn't. And it happens in the presence of tools and technologies which, again, either support the process-oriented thinking or they don't. And the big goal of DevOps is to make sure that the process flows and we have the correct social and process environment supported by the correct tools and technologies in order to make it work. But notice the process is in the middle of this picture, and the process is the biggest part of this picture. And the biggest participants in that process, the biggest components, are the people who are involved in the process. Okay. Related terms to DevOps, just so that you know what people are talking about when you hear it. And I will just mention here that this presentation tends to be a little slanted towards Java environment, and so we'll talk about Maven, we'll talk about Nexus, we'll talk about Jenkins. Jenkins spans different areas, but obviously Maven and Nexus are a little Java specific. That's not to say that DevOps depends on Java or Java depends on DevOps. It merely reflects our focus at WebAge anyway, on well, not even focus. Our largest sort of demand is in the Java world, and a lot of what we try to do is reinterpret the DevOps needs and the DevOps policies and procedures and implementation for the corporate environment, which tends to be largely Java. We'll talk about that a bit later. But DevOps kind of grew up in the Wild West of Silicon Valley and is currently moving into corporate environments, or beginning to suffuse corporate environments. Anyhow, Maven. Apache Maven is a build system for Java projects, which turns out to be actually a huge step in DevOps. And it's kind of funny because Maven was developed, entirely without any knowledge of DevOps. But here's the thing. Maven allows for automated and repeatable builds of a system, including significant amounts of testing and internal quality assurance for a system. It handles dependency management, it handles packaging and release, and there's an ecosystem around it. So there's Maven Central, plugins, Apache Ivy, Gradle, a lot of things use the Maven ecosystem. And what's kind of interesting about Maven in the DevOps scenario is that Maven has opinions. Maven has opinions about how you should organize and manage software projects. And guess what? It turns out that a lot of those people that formed those opinions and wrote Maven to implement those opinions, we're in the DevOps mindset. and as a result, Maven turns out to be, in the Java world anyway, turns out to be a crucial part of continuous deployment and continuous integration model. Apache Ant is a build system for Java projects. We mentioned this in the DevOps framework, or the DevOps context, simply because we need to build tools, and we also need to build software. And guess what? Ant is at the core of a lot of software construction in the Java world. Slowly being replaced by things like Maven and Gradle, but Ant is still quite prevalent. It's also very useful for creating some of the tools that we would like to use in DevOps, and of course very familiar to Java developers. So very popular historically, still used a lot. I'm not sure if I'd recommend starting out a new software development project with Ant as the core build system. I would tend to recommend Maven now in 2016, but certainly for tools and for doing a quick script that happens to be portable across systems and integrates well with continuous integration, we can't do much better than Apache Ant. Apache Ivy is a dependency management system for Ant builds that how it fits with DevOps is the idea of building software in an automated fashion. And it really corrects one of the historical issues with Ant, which is that we have dependencies, we have software packages that depend on other software packages. Where do those dependencies come from? And certainly in open source, you have dependencies on Spring Framework or Hibernate or whatever. Even within a corporate organization, one department has dependencies on libraries that may have been created in another department. We need to manage that. Maven really made the management of package dependencies possible in the Java world. And then Apache Ivy uses some of that Maven infrastructure, particularly Maven Central, and the idea of package repositories like Nexus, to make that dependency management system retrofittable for pre-existing Ant-based builds. So pretty much any open source components you might want to use is available through Maven Central. And if you have a corporate repository, we'll talk about next in a minute, and that you can put your internal products into a corporate repository and manage it with the same tools that we use for open source. Jenkins. Jenkins is an interesting system. By far the dominant continuous integration system. Originally developed by Sun, or at Sun, by a developer named Kosuke Kawaguchi. It was, like a lot of open source projects, developed as a hobby or a side project, and published as on Sun's collaboration site, java.net. Around 2005, and by I'd say probably 2007, 2008, it was the dominant continuous integration system. Continuous integration is a system that allows us to have a software build take place automatically, either based on time or based on someone has checked in code to a revision control system, and we get a software build that happens without any human intervention. Why is that good? Because as soon as we take human intervention out of the equation, we know that we have repeatability. We know that we have the mistake proofing. We don't have the potential errors or forgetfulness that people bring into it. And it also can do a lot of the grudge work, grunt work or drudge work that is involved in doing an integration and packaging. So Hudson was originally, well, Jenkins started out as Hudson, and through some interesting political maneuverings and interesting social developments stemming from Oracle buying Sun, it turned into Jenkins in November 2010. Hudson's still out there. It's part of the Eclipse Foundation, but Jenkins is more active. Are the dominant continuous integration systems out there. Sonatype Nexus is an artifact repository. Now, I mentioned that when we are dealing with process, we have steps in the process and things move in between steps. Okay, in a physical process, like a manufacturing process, if you're putting together a calculator, we have things that move. We have a pile of keypads and a pile of batteries and a pile of circuit boards and a pile of plastic cases, and someone assembles that, and some assembly, some physical thing moves from step 1 to step 2 in the process. And from the circuit board assembly to the final test process, we have a collection of 20 circuit boards, whatever. In a thought-based process, in an intellectual process like software development, what are those things? Well, those things are files, and more generically, artifacts, the result of work, the result of thinking, the result of processing is an artifact. And it becomes critical to manage those artifacts. The big difference between a physical artifact and a thought artifact, an intellectual artifact, is that a physical artifact, has a particular location. I know there's only one of them, and if it's old, I can see it gathering dust. And if I have an old artifact in a physical process, I'm more likely to toss it into a trash can. But we don't have that with a file. How do I know that if my final product is customer system.ear is the file? How do I know that that copy of the file is the most recent copy or the copy that I should use to install on my system? And the answer is we need some metadata and we need some management around those artifacts. We need to track those things. Sure, we can track a digest of the file. We need a system that will do that for us. That's what an artifact repository like Nexus or Arcava or Artifactory does. So it acts as a local copy for everything that's in Maven Central. That's one thing, but what's in Maven Central? Just files, artifacts that are the products of software builds. So Sonatype holds files or artifacts like jar files, install files, web app archives, and so on. Allows you to set controls on who can put files in and pull them out. And again, there's just some measure of control over proliferation of these artifacts. If all we have is we're going to say a file is an artifact, everyone in the building could have a copy of that file on their PC, and we don't know what it is. So, what we try to do with artifact management is to designate one or several areas of reference or machines of reference where we know that if I go to that machine, I can get that artifact, and I can prove that this artifact is the artifact I should be using. So Sonatype is one of these artifact managers. It's available as Nexus Open Source or Nexus Professional. Another of these managers is JFrog Artifactory, another artifact repository which acts as a local copy for everything that's in Maven Central and other things. Okay, the artifact management issue has been pervading software development, and we're starting to see other package managers come on the scene, things like NuGet for .NET files and NPM for Node.js files. And JFrog, Archive, and Sonatype will all handle other types of files. It holds artifacts and allows you to set controls on who can put files in and out. One artifact repository that I don't think gets quite enough airtime, probably should get more, is Apache Archive, which is an open source artifact repository, part of the Apache Software Foundation. And again, it's a perfectly functional manager. It just happens to be free. You got to do your own support. But if you're amenable to open source, it's an option to look at. Okay, other tools that come into play with DevOps. Chef is one that gets a lot of airtime lately. Chef, Puppet, Ansible. These are infrastructure management or provisioning systems. Chef works on the idea of having a machine, gets an agent installed on it, and when the provisioning or infrastructure management, think in terms of bringing up a new machine or bringing up a virtual machine image from scratch. It starts out with nothing, but in the end, in order to be a functioning part of our service delivery system, it needs to have software installed on it. It needs to have software installed into that software. It needs to have configuration applied to it, etc. Chef is an infrastructure management system that manages this with an agent system. So computers get a Chef agent installed on them, which is a piece of software which periodically, when the machine starts up or on a regular basis, calls up the Chef server, which is a central configuration point to find out what software should be set up and what configuration should be done. Chef is kind of interesting in that it contains those the setup specifications in a Ruby program, actually called a recipe. And it is actually running a program, which means it can be sort of dynamic in scope. It can figure things out as it goes along, and it can make adjustments based on the machine that it actually sees. Set up for the whole machine is called a cookbook. So a cookbook consists of a set of recipes that set up the whole machine. Chef is open source. It's created by by Chef Software Inc., which used to be called Ops Code. Although a little side trip into open source. It's open source in the form of you can get the code, you can use the code, you can contribute to the code, but the management of the project is actually a corporate project. So it's operated by Chef Software. As opposed to something like your traditional Apache style open source, where the management of the project is a collaboration among unattributed committers. In any case, so Chef operates a software as a service they call Hosted Chef to host those services, but they're primarily there to sell the service and provision of it. Usually tied in with cloud deployments and continuous delivery. And this, again, just kind of as a comment on DevOps, going hand in hand with virtualization, used to be that, when we got a new server, it was a big, a big thing, and people would gather around and we'd see it rolled into the server room, and the process of setting up software on it could take days, and the process of doing an update on it could take days. Now with virtualization, a new server is I type about 100 characters on my console, and boom, I get a new server. And then what do I want to do with it? And so, the management of those servers becomes a step that we really do need to automate. It's really not acceptable to be secure shelling into your servers and setting them up, individually and lovingly in 2016. Other options, Puppet is another infrastructure management systems, and again, it's agent-based. Computers get a Puppet agent installed on them. The agent talks to the Puppet master to find out what software should be installed on the machine. Configuration scripts or defined states are written as Ruby scripts, and it was originally open source and created and supported by Puppet Labs. There's another one that is Ansible, which is agentless, which is kind of interesting as well. We are looking at beginning some support for Ansible. Anyway, Docker, another buzzword that gets a lot of airplay in DevOps. Docker is a deployment environment for Linux-based services based on Linux containers. And lest anyone tell you that this is Linux focused, I just want to do a shout out to the genius of Sun Microsystems. Linux containers were inspired by Solaris containers, and Solaris containers were actually out probably first. Solaris had containers as far back as 2003, 2004, whereas Linux containers were a little later coming on. However, having said that, Solaris containers were inspired by a short-lived initiative by Caldera and SCO, which was so-called brands, where they were actually trying to run Linux inside or Unix inside a Linux container, and then Solaris came along and said, okay, well, let's run Unix inside Unix, and then later on Linux inside Unix. So Docker is a form of virtualization. We have multiple computers that are on top of one real computer, but it's lighter weight. The containerization that goes back to Solaris 10 and Linux containers doesn't separate out all of the hardware drivers and so on. So it's not simulating hardware so much as providing a software environment where processes in the so-called virtual machine or the container or the zone, whatever you want to call it, are still scheduled by the master controller, by the master operating system. This is lighter weight, tends to be a little faster, tends to share more memory, tends to be less intensive on resources. Big thing is a rapid deployment, and Docker in particular has this idea of a Docker image repository. So instead of having to create a new virtual machine and install software on it, what we do with Docker is create a pre-configured image, or lack of a better word, file system or picture of a hard drive. And then we put that into a so-called repository. And there's that repository idea again, and it's really not far off of the Nexus or Arcava kind of idea, where we have artifacts that are being created. In this case, the artifact is an image of a machine that we're going to use. In any case, Docker instance can retrieve an image from a central location and run it. So in other words, we don't have to do quite so much installation on a given machine. We create an image, put it into our image repository, and then any number of machines with very little configuration of their own can go and run that Docker image. Okay. Why does it matter in DevOps? Well, encourages certainly scripted deployment and configuration, so that Docker file is kind of actually analogous to the configuration script in Chef or an Ansible playbook. So it encourages scripting. Configured images can be taken right out of development and installed into ops. The argument is with a little configuration, so it's an abstraction technology. Tends to fit well with the microservice architectures that are becoming popular. And again, microservice fits well with DevOps because it allows for deployment of individual pieces with less friction to the deployment, I guess is the best way to put it. And that turns out to be really important, so we'll talk about that a little bit later. Okay, Git. Not specifically related to DevOps, but just as an observation, just about every DevOps tool you're going to use wants to use a Git repository. And Git is rapidly becoming the prevalent version control system. So Git was created by Linus Torvalds in 2005, prompted as many great things by some political and social upheaval that started with an argument, prompted by the withdrawal of BitKeeper from the Linux kernel dev project. And Git was designed with the Linux kernel development in mind, which has some interesting features which turn out to have some parallels in the corporate world. So the kernel development is big. It has a lot of distributed responsibilities. Even though Linus is the so-called benevolent dictator for life, he delegates a lot of the responsibility for choosing what patches get into Linux to what he calls his lieutenant. And that turns out to be not a bad representation of a lot of corporate deployments, where we have a product manager and a number of people who are responsible for different pieces of the product, and feeds into an overall picture. It has the ability to selectively apply patches, because Linux is famous for looking at a patch and saying, that's a pile of doggy doo-doo. I will not put that into the kernel, but I like this part, and we'll put something else in. Git, the kernel, like any kernel, is big and has nonlinear development, thousands of parallel branches. Once again, it is large, and Linus took that environment and translated that into design goals of speed, simplicity, and fully distributed development, which is probably the biggest powerful thing about Git, and the thing that makes it the most difficult to incorporate into a corporate environment. And that's what, when we train in Git, that's the big thing, is a distributed environment. Although we dig deeper, that's the environment that we have in a corporation. That's not the environment anybody wants in a corporation. So we have a little bit of tension there. Right. Git turns out to be kind of critical in DevOps. Git also has the distributed nature of it supports itself or lends itself to this idea of artifacts moving from one step in the process to another. And Git thinks of this as changes that are pushed from one repository to another. So a lot of convergence there. Microservice architecture is sort of like SOA. It tends to be a little smaller in scope than SOA. The idea is application architecture, and as such, we don't think of a microservice architecture spanning the entire corporation, whereas we did think of big SOA as having services that represent the functions of different divisions or different service providers. Microservice architecture is more of an application architecture. So the governance requirements are a lot less than SOA, but what it does lead to is applications that are built as components, which are relatively independent, defined by what should be a fairly well-defined contractor interface. And as such, they're readily replaceable, which leads to less friction and better and easier deployment than we would otherwise have. So we see microservice as being really critical on the development side of DevOps. It's a popular approach to application architecture. Okay, so there's kind of an overview of what DevOps is and some of the terms that you'll encounter in DevOps. But DevOps is, and I can't emphasize this enough, DevOps is about process. Tools are a result of attempting to optimize a process, and tools or selection and implementation and development of tools are a result of seeing where the process could flow easier. And so, that kind of focus on process is something that I think is revealed quite vividly in the Puppet Labs report, which you can get a hold of from Puppet Labs. This is a report that's Puppet Labs. I mentioned that Puppet deployment system. Puppet does a survey once a year, sponsored by PricewaterhouseCoopers in association with magazine/website IT Revolution. And they survey 20,000 technology professionals and come up with some conclusions from it. The survey is actually, it's an interesting read. There are, some sections that are salient and some are not as salient, but I'll encourage you to go look at Puppet Labs. Just look up Puppet Labs survey, and I think it's the first result that pops up on Google. The findings for the survey that was done in 2015, hence State of DevOps in 2016, they found that high-performing organizations, and read that in brackets, those who have adopted DevOps, have 60 times fewer failures than lower-performing peers, where failures are software failures, or we deployed something wrong, or we have to replace a component, or whatever. They recover from failure 168 times faster. That sounds like, how can we possibly mean that? Well, think of it as, a recovery in 15 minutes versus a day, okay, is about 168 times. They deploy 30 times more frequently. Okay, how many times did your, ask yourself, obviously although I'm curious, you don't really have to type it in, but ask yourself, your main website system or your main operational system, if you're involved with the purchase order system, how many times did that get deployed in the past year? And a lot of us will say, well, we had, a release quarterly or maybe a release monthly. And DevOps sort of leads us into smaller, more frequent releases. So we even think in terms of daily or weekly. They have 200 times shorter lead times. Think about implementing a little feature or a fix. We found a typo in one screen, and does that get fixed in a day, or does it take until the next annual revision, or does it even keep getting pushed off because to fix it would require going through QA again, and so we end up with a typo that's been in a system for years. The 200 times shorter lead times means things move faster and the velocity of the software development is faster. If you accept that velocity of software development, or that software is critical to your business, that means that the velocity of your business development can be potentially a lot faster through DevOps. The survey found that lean management and delivery practices are key for some definition of lean, and there's a lot of possible takes on it. The types of apps don't really matter, greenfield, brownfield, or legacy. I did a course a couple of months ago that was a Jenkins, the group was doing some Jenkins training, and the group was actually a COBOL development group, a bunch of mainframe developers, and doing some updating and porting to a new COBOL environment, and they were building their system with Jenkins. And so the app doesn't really matter. As long as they're architected with some degree of testability and deployability in mind, high performance is achievable. However, as an observation, microservice architecture tends to be highly correlated with this, fast delivery and lack of failure performance. Here's one that I think is really salient, and if there's one thing that I'd like you to take away from this webinar today, it's this: deployment pain is indicative of IT performance. If we have a high amount of pain, or pain is maybe a loaded word, a high amount of friction in our deployment of a software system, that will lead to low performance. And it's a leverage effect. It's multiplied many, many times over, simply because if we have friction, if we have limitations to deployment, we will inevitably have people put in systems or take steps that seek to minimize that potential for problems. Okay, and to put that in concrete terms, if I think that if we have an error, if a problem is discovered in our operating system, our software system, if I think that's going to lead to the president marching up and down screaming at people, okay, I'm going to make darn sure that doesn't happen. Okay, I'm going to make sure that not only I go over the code with a fine-tooth comb, I'm going to have 3 of my associates go over the code with a fine-tooth comb, and I'm going to make sure that if the president does go stomping around yelling at people, he has no reason to yell at me. So I'm going to make sure that I have a quality assurance report that means that I've demonstrated that I have no reason to think there was any problem. And if there was a problem, it sure as heck wasn't my fault. Okay. That kind of thinking runs rampant in a lot of organizations, and it all goes back to the deployment pain. If we can make it so that if we discover a problem, okay, we discover that we're rounding pennies the wrong way or rounding nickels the wrong way, we can fix it, and it's a question of doing 10 lines of code, running it through some automated test, and hitting the button on deploy to production. Or if we roll out a feature and we find that that feature doesn't work, if the result of that is that I go and flip a feature switch and push the button for deployment again, and that feature is gone in 15 minutes, then we're more willing to take risks, we're more willing to try things out, we're more willing to actually let things happen. Okay, so deployment pain is indicative of IT performance. If we can reduce the deployment pain, we set up the environment for effective operations. And speed and reliability are not mutually exclusive. I know we always joke about pick price, quality, or delivery time, and you can get 2 out of the 3. But that's not actually true. By making sure that our process is aligned, we can move quickly and we can move reliably if we have enough mistake proofing in place. Okay. Lean thinking, and here we get back to the DevOps process ideas. Lean thinking is kind of a thought process that comes out of, in fact, if you go to like the Lean Management Institute, lean.org, they're directly drawn from the Toyota production system. It actually draws out of some consulting companies that worked with Toyota in the early years. But lean thinking really embodies a lot of manufacturing thinking, and after the manufacturing sort of world has declined, it has actually declined. We have more manufactured products than ever, but we leaned out manufacturing to the point where it's no longer the dominant supplier of jobs in the economy, which leaves a lot of engineers that needed to work elsewhere. And so we see lean thinking starting to pervade into other areas and into intellectual processes. So lean thinking says map your development and deployment process. Treat it as a process, a series of steps or sequence of steps that we can analyze how long those steps take, what do we do during those steps, how long, how much effort is expended during those steps, what are the inputs and outputs of those steps, and did the outputs contain significantly more value than the inputs, which is probably critical. And so we define the artifacts that move through the process, and hence that's why that artifact management becomes really critical. Deployment then is a pipeline or a process that connects different environments. So we go from development to integration to customer test to production. In this example, your examples may be entirely different. What we say in DevOps though is, this isn't a normative example. What we're saying is write down what your process is, but realize that you have a process even if nobody's ever bothered writing it down. Speed is maximized when the time spent in any one process is minimized. So if we reduce the amount of work, we reduce the amount of time, and deal in smaller batches, smaller pieces. That's one of the reasons microservices let us move a lot faster, because we're not recertifying an entire system. We're recertifying one portion of a system when we go through test. So the amount of work in that piece is less, and hence the overall pipeline can be faster. As a side effect, quality is easier to accomplish with less work. The less times we touch things and the less times we have human hands on something, the higher quality it is. And actually, just as an aside, my personal background is in electronics manufacturing before I got into management and information technology. And the rule in electronics was, supported by all kinds of studies, that said the number of field failures was directly correlated to the number of times a human being had to touch that product. And I think the same thing happens in software development. The more we can automate, the less randomness and less variability that we have in the system. Okay. So that's sort of interesting conclusions from the Puppet report. I'll just briefly mention a few of our offerings through WebAge and Avnet. We tend to think, actually, despite the name, DevOps has two audiences, developers and operations, and they do have slightly different interests, but there are some common interests in between them. And so for developers, probably likely to be interested in things like containerization, developing and architecting for, by which we mean this idea of microservices, the idea of subdividing and cutting down the size of the releasable components of a system. And so architecture becomes important there, and also the actual mechanics and development techniques for those. Microservices architecture, service-oriented architecture. There's an emerging area of scalability, which everyone seems to be interested in. I think it probably is a little bit overblown. I talked to, many people ask me about big data and ask me about distributed systems, and then I'll ask them, okay, so what's the size of your database and how many users you got? And if you're supporting 200 users, even if they are spread across the country, it's not a scalability issue. Similarly, there's a lot of emerging thought that comes out that some techniques or some types of data analysis are sort of more amenable to traditional database than big data. Anyway, scalability is maybe a little overrated, but that is a concern of a lot of developers. As far as operations, operations primarily concerned with deployment and operation of systems, obviously. And so fields that are interesting to those people probably would be around Docker, virtualization, cloud, services infrastructure, and monitoring and data collection. So shared interest between them, things like continuous integration and Git version control, and to some extent repository management. Okay. Along those lines, we offer a course, Introduction to DevOps, which is 3 days, gives a nice DevOps overview. We talk about Puppet, we talk about Chef. There's a typo in there, it should be Chef, not Chev. Although, being a Springsteen fan, who doesn't love a Chevrolet? Docker and Jenkins. WA 2451 is Intro to DevOps, that's 3 days. More on the development end of continuous integration with Maven, Jenkins, Artifactory. We have WA 2308. If you're just interested in continuous integration, we have a 1-day program, WA 2271. Really prepares you to set up a Jenkins instance and set up a distributed Jenkins instance and configure it, run some jobs on it. 2321 is same course as 2308, but a different selection of tools. It's got Nexus instead of Artifactory. 2404 is kind of an interesting one from the development perspective. Managing software dependencies and artifacts really talks about how to think in terms of artifacts in software development, and then manage those artifacts through creative use of build systems and artifact management systems. WA 2420, Managing Infrastructure with Chef, is a new course that we have out, 2 days, and covers setting up Chef, what is Chef, setting up the Chef server. Introduction to Git is a 1-day program, excellent for corporate developers to kind of get into the Git mindset, which is radically different from anything that you have probably used before. Puppet configuration and admin, WA 2454, and then we've got a few course offerings in the pipeline that should be coming out in the next 6 months or so on microservices architectures, Docker virtualization, and we also have a course on Ansible that is coming along. Okay, so that's about what I have to say. I'm happy to take questions at this time, and I think Laura is going to pipe in and read off some questions to me.
That's correct. If anybody has questions, please feel free to utilize the chat feature. Just type in your question, and we will try to answer as many as possible. We do have one question for you. Greg, you mentioned at the beginning that DevOps concepts are more aligned with Java development. What are its analogy for Microsoft platform?
Okay, let me just expand. What I said was that this particular presentation is more aligned with Java. DevOps certainly has been coming into being integrated with on the Java platform. The challenge has been, and actually we see this sometimes on the Java side as well, certain development environments, and I'm looking at Rational Application Developer on the Java side and Visual Studio on the Microsoft side, tend to be sort of high touch and don't tend to encourage a lot of automated builds. And so, or probably a better way to put it is, it's not that you can't do build automation in those environments, but many developers never go down that road. So on the Microsoft platform, I guess, can I back up? DevOps is certainly available for the Microsoft platform. If you look at TFS, Team Foundation Server, has a lot of elements of DevOps to it. And Microsoft has been really aggressive in adopting Git, and their efforts in the Azure containers and the Azure virtualization have really supported a lot of DevOps. Interestingly enough, a lot of that has come along with Microsoft supporting and adopting different technologies. Microsoft turns out to be one of the emerging forces behind Node, and one of the emerging forces behind several other open source projects that have come along. So, the thinking of DevOps is really to treat your software development process, and you can certainly do that with Microsoft technologies. And things like Microsoft NMake and the NuGet for package management are there. So it's just that our experience with WebAge, we tend to have been historically a little more focused on Java. We're initially adopting more or expanding more into things like Node and JavaScript-oriented technologies. But the Microsoft world is certainly there.
We have another question from a registrant asking for your recommendation. When comparing IBM Bluemix with Jenkins, which do you prefer for integration?
Yeah, that's a good question. Bluemix is a mixture of a number of technologies. I am a big fan of open source as a development methodology, and Jenkins, although it's sort of not officially part of a foundation, is very much open source. So I like Jenkins, but having said that, there's a lot of shops who are very happy with the IBM product line, and of course, the advantage with IBM is nobody ever got fired for buying IBM, and the support is available, and the training is available. So I can't say anything negative about Bluemix. I happen to like the open source approach, but if you want one package, yeah, have a look at Bluemix. Be aware that there's a lot of components and IBM is a huge supporter of open source, so there's a lot of components that are drawn from open source projects. And if you want to experiment with a lot of those products, you can probably get a good idea what's going on by looking at the underlying products as well.
I don't see any further questions at this time. Did you want to maybe wait another couple seconds, or? Oh, actually, we do have another question. Yes, the same person who asked the previous question. I'm from Infra Operation Management, so for me, which course do you suggest?
Tend to suggest something like the Intro to DevOps, or if the tool selection is in your wheelhouse, the continuous integration. But Intro to DevOps is always a good thing. Or if your organization has already selected some of the tools, we have a lot of people that just need training on what somebody else in the organization has already picked. But I think it was the 2451 or 2452. I think it is the Intro to DevOps.
Well, we're just approaching the top of the hour now, so I suggest that we wrap up now. If anybody here does have questions or needs to get in touch with the presenter, then you can feel free to reach out to us at avnet.me/contact. Just fill out the form and we can get you in touch with Greg here.
And thank you so much for your time.
For your interest in Avnet's webinar today, The Current State of DevOps in 2016. We will be sending a link of the playback in case if there's anything that you missed or wish to review again. Like I said before, you can contact Greg or me using avnet.me/contact to discuss any of these topics in further detail. Thank you for attending, and please enjoy the rest of your day. The webinar is finished. You may now disconnect.